is that I changed it from the equation we were looking at. We can solve over here the equation we were looking at, which we kind of already did, right? If you're solving sine of 2x equals 1, what you do is you just look at this and say, oh, I don't care what this is, it's something. I'm just going to call that something. It's going to be sine of something here equals 1. And you solve for the something the way you always have done. If sine is 1, you look for solutions there. And you say, well, one of them is pi over 2 because that's a place where it's 1. But since I'm going to divide them in the end because the something is actually 2x, right? 2x is this value here. I need to get the next one, right? And the next one is, if you think about the graph, right? There's 2 pi. The next one is 2.5 pi, 5 pi over 2. So you actually need to put this one down here, 5 pi over 2. 2x is equal to those two things. So if I want to know what x is equal to, when I compress them, it's actually equal to pi over 4 and 5 pi over 4. That's why there's those two solutions. You got to look twice as far. If you're looking for x between 0 and 2 pi, and this is a 2x here, you need to look for 2x up to 4 pi here. Okay, so you have to look twice as far. You got to look at more than one turn here. That is something that makes this tough, understanding that concept. Some people, we suggest that instead of writing 2x there, they just give it a different name. Like I called it something over here. You could call it m. You could say, I'm going to avoid my confusion by calling 2x m for a while. Right? And just saying, I need to solve for m up to 4 pi because I'm going to divide in the end, right? If you say m is 2x, then you're solving sine of m is a half. Okay, if you're solving sine of 2x is a half, you can say, I don't want to deal with the multiple angle there. I'm just going to give it a name and call it m. And then I'm going to solve it the way I always have done for this, except that I have to look up to 4 pi now instead of 2 pi. You solve the way you always have done, whether it's with the calculator or with the exact value triangles. You find the reference angle, happens to be this. You find the values for that. But then you have to remember, well, it's actually 2x. If 2x is equal to all those values, you got to divide them each by 2. And you get those values. If you want to use this dummy variable, something that stands in place of it, dummy variable, right? Crash test dummy is something that stands in for a person when they test cars, when they crash them up. A dummy variable is another variable that you don't really care about. You're just using in place of this to make it easier. Okay? That's like, there's not a lot to it here other than dealing with that however you want to do that. Okay? You cannot use the m. Please don't look at this as I have to copy it all these steps. If you want to just do it as I'm just solving for 2x the whole time and always write down 2x, that's fine. And realize in the end you got to divide by 2, absolutely fine. As long as you realize the key is that you have to go farther, because when you compress them down, you end up with more solutions. What you could do is still, and we're going to have to get into this later on here, what you could do is look at finding the first couple and then just thinking about how far apart they are. That would be the alternative here. The alternative would be to find the first few and look at the period of what you're looking at. Okay, so this is kind of an alternate way to look at it. Let's look at that in this case here. If you're solving sine of 2x equals a half, you can just say, I don't care what this is. I'm going to look at where sine is a half. Positive a half is these two values here. 5 pi over 6, except there's a 2, so I got to divide them both. And 5 pi over 12, except I got to look at the period of this thing. Sine of 2x, what's the period? What's the period of y equals sine of 2x? Period. What's the period of this? What does that 2 do to the period? It's not 2 pi, it's 2 pi divided by 2. It's pi. You can write a general solution for this and say it's pi over 12 plus multiples of pi. 5 pi over 12 plus multiples of pi. And then just see, are any other ones up to 2 pi? If I added on pi on here, what would I get? Pi over 12, what's going to be the next one? If I add on pi here, what's another one it's going to give me? Pi over 12 plus pi, 13 pi over 12, so that's within what I want. And 5 pi over 12 plus another pi is going to be 17, right? Because certainly if someone gave you this one, sine of 6x, there's going to be a lot of solutions there. How many solutions are there going to be to that? Sine of 6x equals a half. How many are there going to be? Well, for how many cycles are there going to happen in 2 pi here? Well, if it's 6, there's going to be 12 solutions because there's going to be 6 cycles, right? A whole bunch of cycles. This is the number of cycles in 2 pi. If each one of them has 2 solutions, there's going to be 12 solutions. So you might just decide, I'm going to find the first couple and then just keep adding on multiples of the period. The first couple here would be the same, right? Pi over 6, 5 pi over 6, but I got to divide by 6. Pi over 36, 5 pi over 36. And then just think about what the period is. What's the period? It's not 2 pi, it's 2 pi divided by that number, so it's pi over 3, right? The period's pi over 3. To get the other solutions, you say...
My apologies. It is Wednesday, and I will do the announcement.
Okay. I'll leave you for that to think about.